All right, so let's get started on today's meeting. So what we're going to do today is we are going to round out our look at the t-test. So we began with the one sample t-test, and that's where you were introduced to SPSS. And then last time we took a look at the two sample t-test when you have two different groups of subjects that are treated differently and then compared to each other. And today we're going to round out our look at the t-test with the final type of t-test, which is the paired t-test. And that's when you compare subjects specifically to themselves. So each subject is measured twice, and then each subject is compared to their own scores on those two measures. So we're going to be doing all of this using SPSS again. And this is now, we are knee deep, we are well into our look at inferential statistics. That's what these significance tests are. They're our way of going from the sample of subjects and individuals that we measured to the population that we as psychologists are looking to help. And today we're going to continue on with our Do It With Me demos in SPSS, and we're going to take a look at, if time allows, 3 classic psychology studies. 2 of them are going to be a 2-sample t-test, and then 1 will be the paired t-test. So what's on the schedule for today? What we're going to do, as mentioned, some more Do It With Me demos. Hopefully you're picking up the pattern that all significance testing follows that 4-step process of state the hypotheses, plan what you want to do, actually do the calculations, and then form the conclusions. So we're going to take a look at applying that procedure to 2 studies. One that takes a look at, is danger arousing? And we've encountered this study previously in this course. And then a new one, are adults better than teens at recognizing emotions? Which took a look at how well are adults and teens able to differentiate between a face that is expressing a neutral emotion versus a face that is either expressing anger or happiness. So is there a difference between those 2 groups? And then we're going to shift gears, not too much, just shift it into paired t-test gear. And once again, we'll have some Do It With Me demos. These are all going to follow that 4-step process. And we're going to take a look at a classic study where the experimental setup indicated that in some cases, in some situations, people will actually prefer and choose to experience more pain, more unpleasant stimulation, even if they have the choice is completely up to them. So in this case, they set up a situation and they actually found that when given a choice, subjects will often prefer to experience more pain, which went against so many ideas in terms of our psychology and decision making. So we'll take a look at that study and how they ran the stats that allowed them to make their conclusions. So once again, we are looking at t-tests, and we are going to wrap up our look at t-tests today and next time we meet. So just as a brief recap, we took a look at the 1-sample t-test, and this is where you have one group of subjects, you treat them in one way, and then you compare the sample statistics to a population parameter. Most cases, you compare the sample mean to the population mean. So whether you have a known population mean, like an IQ score, or a hypothesized population mean, like a preference of 50%, you compare it to a population mean that you have information about. And then last time we introduced the idea of the 2-sample t-test, and this is where you have, it's right there on the tin, 2 samples, 2 different samples of subjects, 2 different groups of subjects, and they are treated differently. So in the classic drug study, one group of subjects will be given the actual drug, the other group of subjects will be given the placebo. So you have 2 separate groups treated differently. And then finally, the one that we're going to introduce today is the paired t-test. And this is used in 2 situations. Most often it's used when you have one set of subjects, one sample, and you treat them twice. So you treat them you measure them once before a treatment, and then you measure them once after. Or you measure them in one condition, and then you measure them in a second condition. So you have subjects that have been measured in two different conditions, and for that you need a paired t-test. The other situation where this is often used, this type of test is often used, and it's in the name, they're paired, is when you specifically pair subjects up with another subject, either because you're matching certain characteristics or because it makes sense to pair them up together. So the easiest example of this is if you're doing a twin study. You have two groups of people. You have twin A and you have twin B. And you might have 20 sets of twins, but you're not going to compare a twin from one set with a twin from another set. You want to compare twins to each other, to their other twins. I'm just realizing that the English for this is not really up to the task. But you want to compare the sibling to their twin. So you would pair them up. And if you have a good reason for pairing individual subjects, for example, if they have to be matched on age, if they have to be matched on IQ, if they have to be matched on some other parameter, then you can also use the paired t-test when you previously match them up on a certain criteria. But by far, this is used most often when you have one set of subjects, you measure them in one condition, and then you measure them in a different condition, and then you compare the two scores across those conditions. And as always, we are going to be using SPSS, and we're going to be applying that 4-step procedure. So step number 1, state your hypotheses, your parameters, your significance level, and the evidence that you have for the alternative hypothesis. Step 2, identify the appropriate inference method and check the conditions. So far we've been identifying the appropriate inference method because I have been doing a lecture on that particular inference method. So next class, we're going to give you a sort of decision tree or a decision path that you can follow to always be sure that you choose the right inference method. But we definitely have to check those conditions. Then if the conditions are met, you perform the calculations, calculate that test statistic and find the p-value. And then finally, you make a conclusion about the hypotheses. In the context of the problem, you compare your p-value to your alpha level, and depending upon which is bigger, you either accept or reject the null hypothesis, and then reject or accept the alternative hypothesis. All right, so let's get going with our first of the Do It With Me demos. So for this, we're going to go back to the Dutton and Aron, some evidence for heightened sexual attraction under conditions of high anxiety. So this is a 2-sample t-test because in this study, just to refresh your memory, they were interviewing subjects while they were crossing 2 different types of bridges. So on the one condition in sample 1, they were on what is known as the control bridge. And this was a stable bridge that was very well enforced. It wasn't rickety at all. It was a very stable wooden bridge. That was one group of subjects. And they were treated, you can think of it, they were treated with the stable bridge condition. On the other hand, there was another set of subjects, and they were interviewed while they were crossing a very rickety bridge. And this was known as the experimental group. And basically what they wanted to test was whether or not fear, the experience of fear, could be misinterpreted as arousal. They wanted to know whether or not you would experience more arousal on that experimental bridge because it was perceived as a more dangerous bridge. It was less stable than you would if you were on the control bridge. So one of the ways that they did this was when they were interviewing the subjects, and the subjects were all males, when they were interviewing the subjects, they gave them, in part of that survey, a thematic apperception test. And the specific image that they used was this one here, item 3GF. And item 3GF and the entire thematic apperception test is filled with images that are ambiguous, right? So you don't really know what's going on here. Many different situations could be depicted by this image here. So the subjects were asked, well, why don't you tell me a dramatic story? Write down a dramatic story that goes with this image. And then those stories were scored for whether or not they contained sexual imagery. And the idea was if you were more aroused, then you would put more sexual imagery into your story. If you were less aroused, then you would put less sexual imagery into your story. So this amount of sexual imagery was basically their measure, their indirect measure of how aroused were these individuals on the bridge. So just to give you an example, I gave you an example last time. I wasn't too happy with it. So this would be an example of the beginning of a story that would score high in sexual imagery. So something like, she freezes at the landing, one hand on the banister, aware of his eyes before she meets them. The room feels warm, too warm, and the steady evening hum seems to hush around them. So something like that would be scored high on sexual imagery. And you can compare that to a story like this, which would be scored low on sexual imagery. So she pauses at the landing to steady her breath, rehearsing the points one more time. The board meeting starts in 10 minutes, and the proposal will either fund the youth clinic or end the project. So this is no sexual imagery here, and it would be a low scoring story. So the question is was there a difference between the mean sexual imagery score for the group of subjects that crossed the control bridge versus the group of subjects that crossed the experimental bridge? And as I alluded to last time, this is an example where a two-sample design is required, because in this case, practice effects or experiential effects would change the experience and the responses of the subjects. So if a subject crosses one bridge and then you ask them to give you a story about that image, and then you ask them to cross the other bridge and give you another story about that image, their responses will change on that second crossing compared to if they just crossed it for the first time. So because their answers would change on the second condition they experience based on their experience in the first condition, you have to split those up. You have order effects, you have practice effects. So you would split them up and just have one group of subjects that were crossing the control bridge and one group of subjects crossing that rickety experimental bridge. All right, so last time there it is. Last time when we met, we started up on this and we actually got through the null and the research hypothesis. So the null hypothesis, you can write it out as the population mean for the experimental population equals the mean sexual imagery for the control population. Another way to write it is that the difference between the mean of the experimental population and the mean of the control population will equal 0. Both of those say the exact same thing, just worded in a different way. And then we have the alternative hypothesis, and this is going to be a one-way alternative hypothesis because Dutton and Aron were basing their predictions on previous theories that showed that other heightened emotions were often misattributed as arousal. So they predicted that fear would also be misattributed as arousal. So they made the alternative hypothesis that the population mean for the experimental population, the ones on the rickety bridge, will be greater than the average sexual imagery in the control population. And the other way to write that is that the average sexual imagery in the experimental population minus the average sexual imagery in the control population will be greater than 0 because we're expecting the experimental population to have more sexual imagery. Alpha level, not explicitly stated in the paper itself. So if you ever see or if you ever cannot find an explicitly stated alpha level, the convention is that is going to be 0.05. And then our evidence for the null hypothesis is the fact that in our sample, our experimental mean for, our mean for the experimental sample, the rickety bridge, is actually higher in sexual imagery than for the control sample. So we can state that as the mean of the experimental sample minus the mean of the control sample is greater than 0. And you'll notice that the order here mimics the order of our null hypothesis. It's just that we have subbed in our sample means. All right. So now we get to go to step 2, and we can check our conditions. So remember that this is a very important step because if you don't check your conditions, you could be violating the assumptions that these tests are based on, and you should not be doing them if that is the actual case. So again, I forgot to put in large sample or normal. I'm just going to change that real quick. Yeah, we're going to allow that. Here we go. So first off, were these randomly selected individuals? And in actuality, these were not randomly selected individuals. So whereas they didn't force anybody to go on one bridge or the other bridge, one of the criticisms of this study was that the people themselves chose which bridge they were going to cross, right? So the subjects themselves decided, oh, you know what, I'm going to go on that wooden bridge versus, oh, you know what, I'm going to go on that rickety bridge. And that always opens up the possibility that characteristics of the subjects themselves accounted for their choice of bridge and their use of sexual imagery. So it could be that people that use a lot of sexual imagery in stories, they just love unstable surfaces. That might just be a characteristic of that group of people. So in this case, do we have a random sample? We do not. So that is strike one. And in this case, you would not be justified in actually doing this test. And then also, do we have a large sample? In this case, we do not have a large sample for either the experimental condition or the control condition. And whether or not they're normally distributed, we don't know. We don't know if the choice of, we don't know if the sexual imagery scores are going to be randomly distributed or not randomly distributed. So in this case, this is the first one of these that we've encountered. You would not actually want to run this experiment as it is. So in this case, what you would do is, and this is what they did as well. They were very clear that they weren't randomly selected. So mention this, make sure that it's explicit, make sure that you let them know that this was a pseudo random sampling. This was a sampling of convenience. We just took people that crossed one bridge versus crossing another bridge. And then in terms of this criteria here, what you would want to do is you would want to stay at that site and you would want to collect more data until we got these numbers here up to 30. So that would be the safe thing to do. But in this case, they decided not to do it, not to collect more data, and they did the test anyway. So we wouldn't do the test anyway at this stage, knowing what we know. But just to kind of show you how a test like this would be done, we'll go through with it, and we will once again do our tests here. So what we're going to do first is we need to take our nicely labeled. We need to take our scores here for the experimental and the control groups. These are their sexual imagery scores, and we need to transfer them in to SPSS. So we are going to copy the entire set of experimental scores, and then we go over to SPSS, and we're going to paste those in. And SPSS is going to do that thing where it'll ask me if I want it to paste. And I will say yes, and then it'll paste a V because I use the shortcuts. So if that happens to you, you just highlight that column, you delete it, and then you paste in the actual numbers. So we have here var 00002, and we are going to change that to, let's change it to imagery. So we're going to change it to imagery. Let's see, is that what I actually used? One moment. I was a little bit more, all right. To keep it consistent, we're going to change that to sex image. All right, apparently I wasn't thinking about what's going to happen when I present this. All right, so we're going to change that to sex image because that's their sexual image scores. That's a good one to jog your memory. And I doubt anybody else, especially me, is going to forget what sex image is. All right, so we have that right there. Remember that in SPSS, the one rule that is going to help you organize all of your data is that every single row belongs to one and only one subject. One and only one subject gets placed in every single row here. So these rows here, these are for the people that crossed on the experimental rickety bridge. So what we're going to do is right next to it, we are going to write experimental. And then we're going to copy that. And using our shift and arrow key, we can highlight all of the cells that are next to the scores for sexual imagery. And then we hit Control V, and we have that group filled all the way down. Now, the next thing that we need to do is we need to put in the control group scores. So we go back here, we go to the control group, we highlight their scores, Control C to copy them, go back to SPSS, Control V to paste, and we paste it right underneath in that first column because that is a column for the sexual imagery scores. And this is the first open row here. So that is where subject 1 of the control group goes. And then this will be the control group. I'll try to spell control. And then again, Control C on that cell, highlight all of your cells, Control V, and you can populate that whole thing very, very quickly. All right, so now we have it formatted correctly. The last thing that we're going to do is we're going to change var 00003, and we're going to change that to group, because that tells us which group each of these subjects was in. All right, is everybody at that point? All right, and then at that point, we go to analyze, we go to compare means and proportions. Again, this one is called an independent samples t-test in SPSS. 2 samples t-test in your textbook. We click on that. Sexual imagery is your test variable. Group actually cannot go into your test variables here because it's a string variable. So even if you were a little bit confused about which one goes where, SPSS will help you out a little bit. So we're going to put group into the grouping variable. And then you'll see here SPSS says, oh, you're going to give me 2 groups. What are their names? Question mark, question mark. So you hit define groups. And then we'll put group 1 as experimental. And we'll put group 2 as control. And then we hit continue. And then we're ready to go. And we can hit OK. And SPSS gives us this. So I was wondering if this version of SPSS wouldn't do this. I'm glad I ran this just in case you come up with this yourself. So this is an error. And basically what it's saying is that the group subcommand specifies an unknown variable or a long string variable. This subcommand must specify either a numeric variable or a short string variable, text found group. What that means basically is that the name that we gave to one of the samples in our groups is too long. So we are going to close this out. We're not going to save it. And we are going to realize that experimental was just way too long. SPSS didn't like it. Now I know what you're thinking. This is the 21st century. This seems like a 1990s problem. Well, here it is. Your little time capsule about what it was like back in the day. So what we're going to do is before we delete all of this, we're going to rename these. So let's just call this, let's keep it 8 or lower. So we're going to call it experim, because that'll let us know that it's the experimental group. And then we can just copy and paste the control because they're not too long. And then we're going to take this group variable, we're going to highlight it, we're going to delete the whole thing, and then we're going to go back to variable view, and we're going to rename this as group. And now we have it set up in a way that is not going to cause SPSS to have a meltdown. So going forward, if you want to be absolutely safe when you're using SPSS, your variable names and your group names should be 8 characters or less. If you do that, not only will it work in every place in SPSS, but it'll also work on all previous versions of SPSS. So if you happen to go work for a company and they have an old version of SPSS that they've been using, you'll still be able to work there and do your studies. So now we can go to analyze. Now we can go to compare means. Now we can go to independent samples t-test. Now we're going to put this group variable into the grouping variables. We're going to define it. We got experim as the experimental. We got control as a control. Now we hit continue. Now we hit OK. And there we have our SPSS output. So does everybody have those numbers up there? All right. Okay, so these are the numbers that we got. And I actually called it Xperi when I ran this to get these slides ready. So don't let that confuse you. We'll zoom in here. And now we're going to take a look at where can we find the information on this output that matches the information that Dutton and Aron got. So they mentioned that the remaining 38 questionnaires, 20 experimental and 18 control. So that's where how many subjects were in each, 20 in the experimental group, 18 in the control group. And subjects in the experimental group obtained a mean sexual imagery score of 2.47, and those in the control group a score of 1.41, T equals 3.19, P, your probability is less than 0.01, degrees of freedom equals 36, and they did a two-tailed test. I'll have more to say about that in just a moment. All right, so where do we find all that information? First thing we check out is that group statistics table, that top table. Don't skip it. Even though you might not have to report anything from this table, do not skip it. Double check that it all makes sense. So for example, in the experimental group, we should have 20 subjects. SPSS tells us, yes, your N is 20, you gave me 20 subjects. We should have a mean of 2.47. SPSS says, well, hey, the mean out calculated is 2.469. Round that up, that's 2.47. It gives you the information that lets you know that you entered in the data correctly. So when we were redoing the groups, it would have been very easy for us to misplace one of the subjects into the other group. This lets us know that we didn't do that. So we also check the control group. SPSS says I have 18 subjects in the control group. We say, yep, that's exactly what you were supposed to have. SPSS says the calculated mean was 1.41. We double check. Yes, that's exactly what's supposed to be there. It gives us confidence that we have entered in that information correctly. All right, now we go to the independent samples t-test down here. And we are going to be in the equal variances assumed top row. 9 times out of 10, that's going to, well, more than that, but that's going to be the row that you typically go with. That is the more traditional, accepted, conservative, safe row. The other one we'll see in just a moment, but for most purposes, you're going to be in that top row. So up here, we have our mean difference. That mean difference is the difference between the two sample scores. So that is if you were doing a confidence interval for the difference between the experimental and the control group, your best guess would be that the experimental population scores 1.06 points higher on sexual imagery than your control population. And if you wanted a 95% confidence interval of that, you can get it right there. There's your lower bound of 0.38. There's your upper bound of 1.7. So if you need to calculate a confidence interval, SPSS will do that for you. But understand that this is a confidence interval of the difference between the two samples and not an estimate for the sexual imagery in each sample. So just be very careful about that. It's about the difference between the two samples. All right, so that's confidence interval, but what about our t-test? Well, our t-statistic is calculated right there, and SPSS also calculates the degrees of freedom. So in a 2-sample t-test, degrees of freedom are starting to get a little bit complicated. It's each sample size minus 1, and then you add those two together. It gets really complicated when we're going to shift gears into ANOVAs. So rely on the SPSS. They calculate your degrees of freedom. So we have 3.185 or 3.19 rounded up for the T statistic. Degrees of freedom is 36. And then for the significance, they reported the two-side p-value, and the p-value is 0.003, and they reported it as p less than 0.01. So in this case, it's exactly the same information. They reported it as less than. Typically now that we have the software, we would report it as equals, but it is the same. P-value that they found. All right, so this is where they got all that information. So the sample statistics the mean of 2.47 and 1.41, we found that in SPSS. The t statistic of 3.19, we calculated that in SPSS. The degrees of freedom, SPSS also calculated that. And then finally, your p-value being less than 0.01, our p-value actually calculated was 0.003, and we have found that in SPSS as well. The one thing, though, that is confusing about this analysis that Dutton and Aron did was that they specifically reported that their p-value was two-tailed. And yet, when you read their paper, they were clearly predicting that sexual imagery should be higher for the experimental group, for the group on the rickety bridge. So this should have been a one-tailed test, but yet they reported the two-tailed statistics. Now, what this means is that basically they were taking a less powerful statistical test to use in their experiment. So a one-tailed test would have been more able to pick up differences between the two groups than a two-tailed test is. So they were basically throwing their power away, throwing their ability to detect a difference away. In this case, the difference was big enough that it didn't matter for the final conclusion. But again, this experimental analysis would have made way more sense as a one-tailed test. However, here they reported the more conservative two-tailed test. So just as a sort of public service announcement, subjects are hard to come by. Statistics and psychology studies, they are precious resources that you don't want to waste. You want to squeeze everything that you can out of the subjects that you test. And if you are going to a two-tailed test all the time and not taking advantage of one-tailed tests when the logic allows you to, you are basically squandering a lot of the power that you get from these subjects, and that's just not a good practice to get into. All right, so that was the results. So in this case, we have convincing evidence that the population of individuals that cross that rickety bridge would score higher in sexual imagery on the thematic apperception test than the population of the sample one controls. So let's make that explicit. I knew I was forgetting something. Let's go back here and we'll pop in some of that information that we had here. So the t statistic of the difference, I knew I was forgetting something. That's 3.19. That is 3.19. Got too many things open at once. The degrees of freedom was 36. And then our p-value was 0.003. And we get that from, again, SPSS, degrees of freedom, and your p-value. Our p-value, let's do this right, 0.001, because we are going to use the actual one-sided t-statistic. And then the last thing we do is we compare our p-value for step 4 here. We compare our p-value to alpha. And if our p-value, if the probability of getting a score this extreme, a probability of getting a difference this large, is lower than our alpha level, which is the level of risk that we are willing to entertain. If the p-value is lower than your alpha value, then you reject the null hypothesis. You make that black ink, and then you accept the research hypothesis. So in this case, we have evidence to accept the research hypothesis, and we can conclude that people that cross the rickety bridge actually do put more sexual imagery into their stories, which means that they actually are more aroused after crossing the bridge than people who cross the control bridge. All right, any questions on that? All right, so let's finish up our look at the two-sample t-test with a more recent study on by Lee et al. And this is on perceiving facial affective ambiguity of behavioral and neural comparison of adolescents and adults. So we're going to take a look at one part of this multi-study paper. And what they did was they basically took a slider that morphs a face smoothly from happiness to anger. So you can have 0% happiness, 25% happiness, 50% happiness, 75, 100, you can basically increase or decrease how happy a face is, and you morph it all the way from happiness to neutral and then from neutral to anger. And then what you do is you basically show these to different individuals and you ask them, hey, this face that I just showed you, happy or angry or neutral? And the subjects would indicate, okay, that one's happy, that one's angry, that one's neutral. And what you can do is you can use these responses to determine how sensitive they are to picking up differences in facial emotions, right? So how good are they at actually picking up these subtle instances of emotions? So they wanted to compare adults, sample 1, versus adolescents, which was their sample 2. They wanted to know, is there a difference between how adults process facial emotion and how adolescents process facial emotion? So this is an example where a 2-sample t-test is absolutely required, because the only alternative to a 2-sample t-test would be to test the adolescents and then 18 years later call them back and test them as adults. So if you want to get this experiment done in less than 18 years, you have to use 2 separate sets of subjects. You have 2 separate sets of subjects. That means that you have a 2-sample t-test. So just to kind of show you the stimuli that they used. So this is an example of one of the face morphs that they would use. And basically you can see that every single face has a different amount of happiness and neutralness in it, or anger and neutralness in it. So for example, these faces here, they go anywhere between 75 to 45% happy, and the rest is neutral. And if you take a look at how good subjects are at recognizing those images, they basically get it right 100% of the time. Every single time they look at those faces, they'll say, yeah, those are the happy faces. On the other end of that spectrum, you have the faces that are 45, 60, and 75% angry, and the rest is neutral. And again, subjects, if you take a look at that top line there, they're very good at recognizing that those are angry faces. And then you have faces that are 85% neutral and only have 15% happiness or 15% anger in them. And those are those 2 faces in the center. And you can see that they're basically almost look exactly the same. And those ones were regularly identified as neutral. But then in between those really easy faces to identify, you have these regions where it gets confusing. And subjects will sometimes say that the face is happy, sometimes say that the face is neutral. And where those lines cross, that is your perceptual change point. That is your basically level of ambiguity. So there's a perceptual change point for happy faces. There's your perceptual change point for angry faces. And we won't go into the details of exactly how these calculations are made, but you can determine how sensitive people are to detecting facial emotions by taking a look at where those points of confusion intersect. All right. So let's take a look at the data that they used for this. So this is still in the 2-sample t-test for a population mean Excel sheet. And this is the Lee et al., Lee, Perino, McElwain, and Telzer, perceiving facial affective ambiguity. So what we're going to do here is, again, we're going to take advantage, well, we're going to test these 2 samples here in a 2-sample t-test. But first off, we're going to calculate some of the sample statistics. And we're going to take advantage of the fact that we've set these up in a way that we can copy and paste them from sheet to sheet. So we're going to go back to the Dutton and Aron sheet, and we're going to copy those formulas for sample mean, sample standard deviation, and sample size. And then we're going to go to the Lee et al., and we're just going to simply paste there in the appropriate cells. And as you can see, once again, it populated that, calculated those formulas for us. And if you just want to double check to make sure, again, you can double click on that and just be sure that it actually is using that entire, yep, got it. It's using that entire column. This is just a nice little shortcut that SPSS allows us to do. All right, so for this one here, we have the null hypothesis. And again, the null hypothesis is always that your 2 populations are going to be equal to each other. So we have the null hypothesis. We have the, different version of the null hypothesis where the mean for the adolescent population minus the mean for the adult population is going to equal 0. And then we come to the alternative hypothesis here. And just give me one moment. Yeah, that's what I thought. Okay. Should have went with my instincts. I do want to make sure I get this correct. And now I'm just pressing buttons that I shouldn't be pressing. All right. So in this case, they had no good reason to predict that the adults would be better than the adolescents or the adolescents would be better than the adults, right? They had no theory coming into it. They had no pre-existing predictions in place. So this is a non-directional hypothesis. It's going to be a two-tailed test. So for the non-directional, we have that does not equal sign. And the reason I put those in the cells so we can just delete things is sometimes that's a little hard to find, that does not equal. But our alternative hypothesis is that the population mean of sensitivity to facial expressions for the adolescents is not going to equal that of the adults. And the alternative way to write that is that the mean for the adolescents minus the mean for the adults is not going to be equal to 0. Our alpha level, they don't report it, so it's going to be 0.05. And the evidence for the null hypothesis is that we have our sample means here, and the adolescent's sample mean minus the adult sample mean, well, that does not equal 0. So we do have evidence already that there might be a difference. Now the question is that difference big enough to be statistically significant, meaning that can we generalize from this population difference that we know exists to, this sample difference that we know exists to a population difference. All right. So first off, random sampling. Were these randomly sampled? We check our conditions. Yes, they were randomly sampled, both for the adolescents and for the adults. And then for the large sample, you can see that the sample size for the adolescents was 100. That's more than 30, so we're safe for that sample. The sample for the adults was 81, more than 30, so we're safe for that sample. So yes to both of those. And we don't even have to check if they're normally distributed. Once we have 30 or more, we know that we're safe to go forward. All right, so now let's actually get some numbers. So we are going to copy and paste the adolescents first. So we copy all of their scores. We go here to the SPSS output. We're going to close the output. If you were doing this for a project or you needed to save your output, you can save your output. For this demo, though, we can just click no. And then also, I would highly recommend that you start a new data. If you needed to save this one, I would highly recommend start a new data editor. But as it is, we can just clear these because we're just doing this for demo purposes. But whatever method you choose, I highly, highly recommend do not have more than one experiment in any data editor. Anything that does not have to be in there is just going to possibly confuse you. You're going to choose the wrong column. You're going to choose the wrong variable in one of your analyses. You're just making things way more difficult for yourself. So we are going to take these adolescent scores, take our fresh data editor, I'm going to paste those in there. And then here we are going to, what did I call this? We are going to call this, really? Yes, that's what I called it. That makes more sense. We're going to go here to variable view. And remember, we had trouble with variable names that are too long. So I would love to call this uncertainty boundary, but that's not going to work. But thankfully, we can just call it uncert, and that brings us up to 6. And then we can just say BD. And to my human mind that's working on this project, if I saw uncert BD, I think I'd be pretty confident in remembering that that's the uncertainty boundary, even if I came back to this a week or a month later. So we have our uncertainty boundary here. And now we need to put in what group these scores belong to. So we are going to put in adolescence. So that is 8. And we probably could have went with teen, but I'm trying to keep it as close to the language in the, oops, forgot to copy, the language in the paper as possible. So once again, copy that first instance, highlight all the way down to your scores, Control V, and you can populate the whole thing very, very quickly. And then we go back to variable view, and this is our group. Sorry, this is our group. And we go back to data view, and now we have our adolescent scores next to our adolescent group. So far, so good. We go back to the two-test demo. We get the data for the adults. So again, highlight all of the adult data, copy it, go back to SPSS. Again, can't put it here because that row is already occupied. We scroll down to the first open row in column 1, Control V to paste that there. And then we indicate to SPSS that this is part of the adult group. Control C, highlight all the way down until you get to your final adult. Control V to populate that. And we have ourselves our data properly formatted. At this point, we can go to Analyze, Compare Means and Proportions, Independent Samples t-test, Uncertainty boundary, uncert BD goes into your test variables. Group goes into your grouping variables. Once again, SPSS will ask you, well, what are the groups? So we define the groups. Notice that it has populated it with your previous groups. So SPSS will do this if you're using it for multiple questions in a row. It will remember what your previous groups were, but those aren't the groups anymore. So we put in adolescent and adult. We hit continue and we hit OK. And we have ourselves our output here. So everybody have those numbers? Okay. So let's take a look at what we have. We'll zoom in a little bit here. But the first thing that we're going to take a look at is what did Lee et al. Find? So Lee et al. In their results wrote that each participant's neutral responses were fitted to the psychophysics model to estimate the uncertainty boundary. Basically, the higher the score, the more uncertainty. An independent samples t-test indicated that perceptual uncertainty levels were significantly higher for adolescents. There's the mean, there's a standard deviation, there's a standard error. Then adults, there's an adult mean, standard deviation, standard error. T, 177 degrees of freedom, the T statistic equals 2.09. P-value equals 0.037, and then they have their 95% confidence interval and their Cohen's D. So let's see where they found that information. So first off, always check your group statistics. So we have for the uncertainty boundary scores, SPSS is telling us you have N equals 100 subjects. So we gave them 100 scores. They found 100 scores in that group. That is great. The mean is mean uncertainty boundary is 45.8. That also matches our calculations in Excel. And then also you can see there where Lee et al. Got their standard deviation and their standard error of the mean for that particular sample. So if you need to report those, SPSS will calculate those as well. And then we have the same information for the adults. We gave SPSS 81 subjects. It found 81 subjects. The mean is correct. Standard deviation is correct. And it also calculates that standard error of the mean. All right, now down to the independent samples t-test. This experiment confused me a little bit for a moment when I saw that the degrees of freedom was 177. Because in the traditional way of calculating degrees of freedom, the degrees of freedom should have been 179. But what that meant was that Lee et al. Were not using the traditional, more conservative way of calculating degrees of freedom. They were using the more new way that has, if you looked in your textbook, that absolutely horrible degrees of freedom formula. But if you do want to use that, it's not incorrect. It's actually probably more powerful So if you do want to use that, it's in the second row here. So, and if you ever see degrees of freedom that don't seem to make sense into your mental calculations, chances are they're using that second row there. So as we can see, the mean difference, the difference between the sample scores for adolescent and adults is calculated right there. If we want a 95% confidence interval for that difference, SPSS will also calculate that. Please bear in mind, note that it is for the difference between the groups, not for the actual perceptual boundaries of each group. And then importantly for our analysis here, we have our t-statistic of 2.09. That's what was reported in the paper. Our degrees of freedom of 176.615. Now it's a little hard to wrap your head around this. This doesn't really fit in with the barbecue selection example that I gave in a previous class, but it is a more powerful way to calculate out these degrees of freedom, and that is where their 177 came from. So for a little bit, I thought they dropped some subjects, they excluded some subjects. No, that's actually where it came from. And then finally, we have their p-statistic, p-value, which is a two-sided p-value, correctly two-sided, because they didn't know, are adults going to be better or are teens going to be better? And that's where you find that information in your SPSS output. So putting it all into the report here, there's your sample statistic for your adolescents. There's your sample statistics for your adults. Those were calculated in SPSS. There is your t-statistic, 2.09. Your degrees of freedom, 177 with that horrible, horrible formula, but it is the more recent way to do it. And then you can see that the p-value matches the two-tailed p-value. So they did theirs correctly, even though they don't explicitly mention it. You can tell that they did a two-tailed t-test, which is the correct one to do. So now that we have all that information, we can enter it into our decision tree here. So we have our t statistic of the difference, and that was 2.09. We have our p-value, and that was 0.037. Whoops. We have our p-value of 0.037. We have our degrees of freedom of 177. And then we have to make our conclusions. So we take a look at our p-value. We take a look at our alpha value. Our p-value is less than our alpha value. So we reject the null hypothesis. We accept the research hypothesis, and we have evidence that in facial perception, the perceptual boundaries are higher for adolescents than they are for adults. So this actually is a really, really interesting finding in terms of potentially explaining adolescent behavior and why adolescents oftentimes don't really do the socially acceptable thing in particular situations. Because one way that you understand what is socially acceptable is to read expressions in people's faces. When is somebody open to hearing a joke? When do you have to be super serious with somebody? And those subtle facial expressions are easier to pick up, or you're better at picking them up when you're an adult. So it might not be that adolescents have an attitude problem. It might just be that they're picking up neutral facial expressions when they, or having difficulty differentiating between happy and neutral, and are acting on it in an incorrect manner. All right. One more test for the day. And this is going to be our first paired t-test, and I hope we get through it. I don't want to rush it. This one is really, really cool. So we'll see how far we get. But here we are, paired t-test. And for this, we are going to go to this absolutely classic study by Daniel Kahneman et al. And it is titled, "When More Pain is Preferred to Less, Adding a Better End." So in this study, they wanted to know, would people in a situation prefer to experience more discomfort than to experience less discomfort? And it makes absolutely no sense in our minds that you would ever choose to experience more pain. However, in this situation, that is exactly what they found. So what was the situation that they set up? Well, they had two conditions. And the subjects experienced both conditions. And just as a sort of aside to this, when you're setting up a paired samples experiment, what you want to do is you want to make sure to mitigate any of the potential challenges and vulnerabilities of that paired sample design. And one of those is order effects. So in a two sample experimental design, you can test all the adults first, and then you can test all the adolescents second. And it's not going to make a bit of difference to how the adolescents respond. But if you're testing subjects twice, then you want to make sure that your order effects do not affect how they are responding. So in this case, we're going to see that they have two conditions. Half of the subjects got the short trial condition first, and then, not surprisingly, it's going to be called long trial. They got the long trial condition second. The other half of the subjects got the long trial condition first and the short trial condition second. So if there were order effects, if there were practice effects, if there were fatigue effects, they would get averaged out across those two different orders. So, and then also they used different hands for the two different treatments, and that was counterbalanced as well. So without further ado, no order effects, those were taken care of. No arm effects, those were taken care of. What is this poor man doing? Well, what they had them do was they had them place their hand into painfully cold water, like ice bath cold, and you would keep it there for 60 seconds. So in treatment one, the subjects would place their hand into ice cold water, 14 degrees Celsius, and they would hold it there for 14 seconds. And then what they would do is, after a period of time where they could recover and everything was fine, they would experience the second condition, and this was the long trial condition. And in the long trial condition, what they would do is they would do the exact same thing as the short trial condition. So you would have your hand in water for 60 seconds, and that water was 14 degrees Celsius. However, in addition to that, they tacked on another 30 seconds, and this was at 15 degrees Celsius, and it was still painful. So one of the things to remember is that 15 degrees Celsius is still painful. It's still an ice bath cold level. And the question was, they actually asked them three questions. After both trials, the participants were asked, which experience had more overall discomfort? Was it your short trial experience or was it your long trial experience? Which experience was more cold at its most extreme moment, and which experience was more tough to deal with? So the subjects would rate their pain level during the experiences on a 1 to 14 point scale. So they would say, all right, you've been through both treatments. For treatment one, give me your level of overall discomfort on a scale of 1 to 14. 1 is low, 14 is high. What's your overall discomfort? And then they would say, all right, and you also went through the long trial. What is your rating of overall discomfort on your long trial? And what they found was that subjects reported the long trial as being less discomfort, less pain than the short trial, even though the long trial, they experienced as much pain in the long trial, plus more pain in the long trial, yet psychologically, for some reason, that long trial was experienced as less painful. So let's take a look at the data for this. So for this, we have a new Excel sheet. It's this one over here, the paired t-test for population mean. So we got Kahneman's when more pain is preferred to less. And then here we have the ratings of discomfort. So we're just going to focus in on the discomfort ratings. And here we have 32 subjects. And the 32 subjects rated how uncomfortable was the long trial on a scale of 1 to 14. And you can see that some of them said I was a 6.6, it was 12, 7.4. They were very detailed. This is hypothetical data, but apparently they were very detailed with how uncomfortable it was. And then importantly, those same subjects were then asked, how painful was it, or what was your overall level of discomfort, 1 to 14, for the short trial? So that's the thing to remember for these paired t-tests. These two scores here come from the same person. The same person gave those two scores. And these two scores here came from the same person. And these two scores here came from the same person. And that is going to be the power. That is where these paired experiments, they're also known as repeated measures experiments, that's where they get their power. Because every single subject acts as their own control. So the more I just want to point this out because this is a very important reason why this kind of test is done. And it doesn't look like we're going to get to it. So we'll set up the null hypotheses and then we'll call it a day and we'll see what happens next time. But that is the power of the paired experiment, the paired t-test, is because this individual here, individual number one, subject number one there, maybe that person is just a brick of a person, right? Maybe they just don't experience pain. Maybe they've been through so much in their life that mentally they are just so mentally strong and they can take anything. So when you gave them the long condition, they said, yeah, you know what? That was a 6.6. That wasn't that bad. And then you gave them the short condition and they're like, you know what? That's a 9.9. That wasn't so bad. So this person might have thrown off the scores if they were only in one sample. However, here, if they're super tough, and that's going to throw off the scores, they're super tough in the long condition, and they're super tough in the short condition. So their toughness cancels each other out because they're measured in both conditions. And if you take a look at the next person here, and let's say that they just have a physical condition that makes them hypersensitive to cold water, and they were just in agony, right? Well, they're hypersensitive in the long condition, and they're going to be hypersensitive in the short condition. So their hypersensitivity cancels each other out when you're comparing them between the two conditions. And if you have somebody, let's see if I can find a super low score here. No, not really. I think this first one was one of the super low scores. All right, so if you have somebody like this, subject number 3, maybe they're a part of the polar bears. Maybe they jump into ice water for fun. And again, they didn't find this to be too painful. Well, they're going to be a member of the polar bears here in the long condition, and they're going to be a member of the polar bears here in the short condition. So the power of this, the reason why, if you can, in my opinion, if you can do a paired t-test experiment, do a paired t-test experiment, is because regardless of factors that might affect your results, those factors get canceled out because you are comparing one person to themselves. So if somebody came into that experiment tired, they're going to be tired in the short trial condition, they're going to be tired in the long trial condition. If somebody came in after getting a raise at their job and they're feeling euphoric, they're going to be euphoric in the short trial condition, they're going to be euphoric in the long trial condition. If somebody just had the worst day of their lives, they're going to have their worst day of their lives in the short trial condition, they're going to have the worst day of their lives in the long trial condition. It works out both ways. I mean, it's powerful because they act as their own control. All right, so let's finish up today by setting up the null hypotheses, and then we will let you think about what might be going on there before our next meeting. So once again, for this is our first time doing the paired t-test, hypotheses. My mind is starting to wind down. The paired t-test hypotheses. So again, I'm going to show you 2 different ways that people often do this. So again, here we have the population discomfort for the long condition equals the population mean for discomfort for the short condition. So again, it's by populations. Null hypothesis is that the 2 of them equal each other. For some reason, I don't like this convention, but this is the one that your textbook uses. They write it as the population difference equals 0 for the null hypothesis. And what that means is basically the mean of the long exposure population minus the mean of the short exposure population equals 0. But they write it as population difference equals 0. So just so that you're aware of that, I put it up here. This is not at all, I think, a good way to do it. This is a way better way to write it out. But this is what's often used in your textbook, so now you know enough to recognize it. All right, alternative hypothesis. For the alternative hypothesis here, Kahneman had some theories about why people would prefer the long trial to the short trial. So Kahneman is one of the founding fathers of decision-making psychology. So they had some theories about why they would prefer the long trial over the short trial. But then everything about common sense and previous psychological studies said that they would prefer the short trial over the long trial. Who would choose to experience more pain? Or who would rate more pain as being having less discomfort? So because of that, we have some theories that say, hey, people should prefer the short trials. We have other theories that say, hey, people might prefer the long trials. So we got theories going both ways. So we're going to do a two-tailed, and we have that the mean for the long exposure population is going to be the same as the mean for the short exposure population. The alternative way to write this is that the difference between the two population means is not going to be equal to 0. So we delete the other things and we have that not equals. Alpha level for this is going to be 0.05. Once again, it's not explicitly stated. And then the evidence for our alternative hypothesis is that if you take a look at the means up here, the sample mean for the long exposure was 8.67 out of the 14-point scale on discomfort. For the short duration, it was 10.44 out of the 14-point scale for discomfort. So we have our evidence for the null hypothesis that the sample mean for the long exposure minus the sample mean for the short exposure does not equal 0. Or, as your textbook likes to say, the sample difference or the sample mean difference does not equal 0. So those are our null hypotheses all set up. And what we're going to do is we are going to hold off on actually running the SPSS until next time when we wrap up our look at t-tests. But one thing to kind of do before then, again, actually maybe two things. Number one, you have the data, you have the Excel sheet. We haven't actually done one of these yet, but if you want to give it a try doing it without looking up a guide online in terms of how to do this. You have all the information that you need in order to do this. And it actually is called paired t-test in SPSS. So use the guiding principles of one row per subject, and then use the variable names and everything. And let's see if you can do it without actually looking up guides. We'll go through it when we come back. But then also try to maybe speculate a little bit about why this actually happened. So why would somebody who has dunked their hands in for 60 seconds and felt pain, why would they rate the condition where they then added 30 seconds more of discomfort as being less uncomfortable, less extreme, easier to deal with than just the shorter trial? So this really seems to make no logical sense whatsoever. However, psychology oftentimes does not make logical sense on how our minds work. So try to think about what could possibly be the reason why this is occurring. Why did people prefer those long trials? I'll let you know what Kahneman came up with, but it would be interesting to see if anybody has any alternative ideas. All right, so any final questions about anything? All right, so that is it for today. So next time we meet, we are going to wrap up paired t-tests, and then we're going to go through one example where we're going to go through a decision tree about to make sure that you always pick the correct t-test, one sample, two sample, or paired t-test. And then we're going to go through a final demo where we run data, the exact same data as a two sample t-test and a paired sample t-test. We're going to compare the outputs that SPSS gives us, and that's going to show you why it is so extremely important to make sure that you choose the right test and run the right test. But all that next time. But for today, we are finished.